Welcome to the deep dive. Today, we're not just reading a manual. We are basically dissecting the brain of an industrial project. We have a massive stack of source material here. Documents detailing health, safety, and environment, or HSE, requirements for large-scale construction.
And these aren't light reading. We're pulling the core principles from three key documents. E2.0, the overall requirements, then E2.1, the life-saving rules, and E2.2, the site rules.
So for you, the listener, what's the biggest takeaway here?
It's this. On projects this big, safety is not optional compliance. It's a mandated management system. It's a structural requirement for critical thinking and, accountability.
Our mission, then, is to show you exactly how complex that structure is, moving past just the surface-level rules to the actual mandated blueprint for a safety culture.
Right, and the core thesis is that contractors have to do more than just follow a list. They must develop, implement, and continuously improve a whole HSE management system. Safety has to be treated as a core value.
And it has to be a world-class system from the get-go.
Absolutely. The environmental parts of the contractor's HSE management system, or MS, are explicitly mandated to comply with ISO 14001. That's an international standard. It tells you the bar is set at global excellence from day one.
Okay, let's unpack this foundational layer, starting with the timeline. E2.0 says the contractor has to develop a detailed HSE MS and an HSE plan, and that plan has to be submitted for review just 1 month after the project starts.
1 month. That time pressure just shows how critical it is. Safety has to be integrated into the execution schedule. It can't be an afterthought.
And a plan is just paper without leadership, right?
Exactly. That's why the policy statement itself has to be visibly signed by senior management. That signature isn't just a rubber stamp. It's a commitment to personal accountability.
And that required commitment leads directly to what might be the most transformative requirement, the stop work authority.
Yes. The HSE policy must mandate that anyone, from the newest person on site to the site manager, has the explicit authority to stop work if they think it's not safe.
And they have to seek help to fix the issue.
That is a fundamental shift in power dynamics. You're giving the critical decision-making power to the person who sees the immediate risk, not someone in an office miles away.
It's the ultimate proof of treating safety as a core value.
It is, and it grounds the whole structure in trust. But it requires action from the top, too. The documents are very specific that senior management must actively demonstrate this commitment.
How so?
They have to lead the improvement of the HSE culture, set an example, and critically, personally, intervene when they see unsafe acts or conditions.
So if the project director walks past an unguarded hole and doesn't stop to correct it?
They have failed. Failed to meet the mandated cultural requirements. It has to be visible, personal intervention.
That visibility is so important. Now, how does this cultural commitment translate into, an actual process? Let's talk about reporting, because this section mandates a blame-free culture.
Right, a blame-free culture for non-conformances and near misses. The goal is forensic analysis and learning, not punishment.
Because if people are afraid of being punished,
they hide incidents. And if they hide incidents, the system can never learn. And to make sure this learning is continuous, the reporting frequency is strict. Records of non-conformances have to be produced at a frequency of not less than weekly.
Weekly? That's aggressive. And where do those reports even go?
They don't just stop at the supervisor level. These trends and frequency rates have to be reported right up to the highest level of contractor management and to the employer. It forces immediate systemic review of failures.
Not just localized fixes.
Exactly.
And on these massive projects, you have dozens of specialty firms. How are subcontractors integrated into this system?
Rigorously. The main contractor has to develop and explain all the HSE requirements to subcontractors right at the kickoff meeting. Then, before subcontractor even gets to the site, they have to submit their own project-specific HSE plans for approval.
That alignment process, is that what they call bridging arrangements?
That's it. It makes sure there are no gaps between the teams.
So once the policy and the structure are in place, how do we know if the system is actually working? That brings us to the metrics and the goals.
Right. The contractor has to jointly develop specific HSE targets with the employer. It creates this one-site team approach.
So no finger-pointing later.
Exactly. Shared accountability. And that feeds directly into the key performance indicators, the KPIs. The documents mandate 2 critical hard number injury metrics.
Okay, let's start with the one most people probably hear about, TRCF.
TRCF. It's the total reportable case frequency. The target is to achieve a frequency of less than 2.0.
And what does that actually mean in plain English?
It's the number of injuries that result in time away from work, medical treatment, or someone being put on alternative duties, calculated per 1 million man-hours worked. For a huge project, 2.0 is a very strict boundary for what is considered acceptable harm.
So anything above 2 significant injuries per million hours flags the project as underperforming.
Fundamentally underperforming, yes. The second metric is TRIF, the Total Reportable Occupational Illness Frequency. For this one, they have to maximize the target, which basically means drive the actual frequency down to zero. Absolute prevention.
What's really fascinating here is the granularity of the reporting. We're not just looking at lagging indicators like injuries. The system demands a focus on leading indicators, the predictive data.
Look at the mandatory minimums for the weekly report. It's a snapshot of the project's health. Hours worked, number of near misses, first aid cases, vehicle incidents.
And environmental impact every single week.
Every week, spills greater than 100 kilograms, detailing both the number and the quantity.
100 kilograms, that is a very precise threshold. They're tracking environmental risk with the same urgency as physical injuries.
And it expands monthly. The monthly report includes progress on safety culture programs and, crucially, the specific volumes of hazardous and non-hazardous waste. It's an environmental audit built right into the performance review.
This all supports the philosophy on incentives, which, as you said earlier, is maybe one of the most insightful parts of this. The requirements strictly mandate that incentive schemes have to be based on proactive measures.
This is a huge governance lesson. You can't base incentives on reactive things like just having zero injuries.
Why not? That seems counterintuitive.
Because if you reward a lack of injuries, you create a powerful incentive to hide a near miss, or maybe downplay a sprain into just a first aid case so it doesn't get reported.
So instead, you reward the desired behavior. What kind of proactive things are we talking about?
Things like excellent housekeeping, robust hazard reporting, enthusiastic participation in safety audits, high-quality near-miss reports. You reinforce that blame-free culture by rewarding the effort to make the site safer, not just rewarding statistical luck.
And it has to be culturally sensitive.
Right, adapted to local norms and customs to make sure it's fair and engaging for everyone.
That brings us to the technical core of the system, risk management. This is where the engineers and managers really earn their stripes. Let's get into the HEMP, the Hazards and Effects Management process.
HEMP is the engine room of all the planning. It's the required process for systematically identifying hazards across every single project phase.
And this covers everything: environmental, social security risks.
Everything. And here's where it gets really interesting. The requirement for a review of constructability during the design phase.
So you're thinking about how to build it safely before you've even broken ground.
Precisely. You don't wait until the steel is fabricated to realize that lifting a certain piece is inherently dangerous. HEMP forces the team to look ahead, to design out the risk before they even start on site.
So that HEMP process uses a risk assessment matrix, or RAM, to classify the risk. What are the required responses for different levels?
It's a scaled response. A medium risk requires a task-specific job hazard analysis, a JHA, a quick, detailed look at the job.
But if the RAM classifies the risk as high?
Oh, then it's a whole different level. It demands a detailed JHA done by managers and engineers. It needs formal employer approval, and you have to use the bow tie methodology.
The bow tie methodology, that's a pretty sophisticated tool, isn't it?
It is. It's a visual way of analyzing a hazard. In the center, you have the bad event, say a crane collapse. To the left, you map all the causes and the proactive barriers to stop it. To the right, you map the consequences and the recovery barriers to mitigate the damage if it happens.
So it forces a complete systemic view of both prevention and mitigation.
Exactly.
But how do you make sure the person on the ground, the one actually doing the lifting, internalizes all that complexity?
That's where the required communication techniques come in during the daily toolbox meetings. The documents mandate specific, memorable routines.
Like what?
The three, what can go wrong, what can cause it, what can be done to prevent it. And the step back 5, which is just pausing for 5 minutes on site, to mentally review the hazards before you start work.
That's turning technical analysis into muscle memory. But let's go to the ultimate level of safety determination for high risks. ALARP, as low as reasonably practicable. This is the big one.
Absolutely. When a risk is high, a formal ALARP determination is mandatory. This is a complex exercise requiring a whole team engineers, supervisors, specialists to document exactly why they cannot or should not reduce the risk any further.
But how do you prove that? Isn't there a tension between safety and cost?
There is, and that tension is exactly why the formal process is mandatory. It forces transparency. First, they have to review all the relevant laws, codes, and good practice, often using advanced methods like quantitative risk assessment, or QRA.
So they establish the industry benchmark first. Then what?
Then they identify control options. And here's maybe the most philosophical part of the whole document. They have to identify options that go one step too far.
One step too far, what does that mean?
They have to consider controls that would be technically possible but maybe unreasonably costly or difficult, and then formally document why those extreme measures were not chosen.
Wait, they have to document the solution that is too expensive or too complicated.
Yes, it requires them to prove they haven't stopped searching for safety improvements just because the first easy solution looked okay. It's an explicit check against management complacency. Only then can they formally justify that the remaining risk is ALARP.
Wow, that adds a huge layer of due diligence. And if, despite all this, a high potential incident happens,
The investigation has to be equally technical. For any high-risk incident, a fatality or major damage, the investigation must be supported with the tripod beta analysis method.
tripod beta, how is that different from a simple root cause analysis?
A simple analysis often stops at human error. The worker didn't follow the procedure. Tripod beta goes deeper. It systematically maps the causation, linking the immediate errors back through preconditions like fatigue or poor training to the underlying latent failures in the management system itself.
So it asks why the procedure failed, why the training was inadequate.
Exactly. The goal is always to fix the architecture, not just blame the bricklayer. It ensures the learning is systemic.
Moving from these complex systems down to specific, non-negotiable behaviors, let's look at the life-saving rules in E2.1.
Right, and the documents mandate adopting these 9 rules as written to ensure standardization across the whole industry.
And standardization is key.
It's vital. It means someone moving from one site to another, even in a different country, will recognize the same critical safeguards for the most dangerous activities.
Give us a few examples of these non-negotiables.
Okay, take the energy isolation rule. You must verify isolation and zero energy before work begins. All sources locked and tagged. You never ever assume energy is isolated.
What about working at height?
The mandate is 100% tie-off to approved anchor points, and you have to secure all your tools and materials to prevent dropped objects, which is a major cause of fatal injuries.
The rule on bypassing safety controls seems just as strict.
It is. You must get explicit authorization before overriding or disabling any safety equipment. You can't just innovate around a barrier to speed up a task.
And this brings us full circle to the culture mandate we started with. The organization has to provide the physical workplace conditions needed to follow those rules.
That's the point. You cannot punish a worker for failing to tie off at height if management failed to install certified anchor points in the first place.
That is profound. It shifts the burden of compliance from purely individual behavior back to the organization.
It does. If a rule isn't followed, the organization is mandated to find out why. Was it training? Was it bad equipment? They have to learn and improve the workplace, not just focus on discipline.
Finally, let's just touch on the massive scope of all this by looking at the required HSE site rules in E2.2. This shows that HSE is so much more than just physical injury.
The sheer breadth is astounding. The health section, for example, must address medical facilities and all occupational health risks: chemical, physical, biological, ergonomic, and significantly, psychological hazards.
Psychological hazards, like stress, fatigue, and workplace bullying, mandated on a major construction site. That's a truly integrated approach to health.
It is. The safety section covers everything from confined space entry and radiography to detailed road transport safety. They manage the risk of the commute as thoroughly as the risk of a heavy lift.
And the environmental requirements embed sustainability from the start, demanding procedures for resource use, emissions control, and protecting soil and groundwater.
And if you step outside the project fence, the social requirements are explicit. A sustainable development policy, stakeholder engagement, community liaison processes. The system requires managing the project's relationship with its community as rigorously as it manages a pressure vessel.
So if we connect this all together, we've journeyed from high-level management commitment and that cultural mandate through these critical technical risk processes like HEMP and ALARP, right down to the non-negotiable behaviors of the life-saving rules.
And this system is not a static binder on a shelf. It's dynamic. It's reinforced by mandatory 3-monthly management reviews and annual independent audits. The system is designed to find its own weaknesses and evolve.
So what does this all mean for you, the learner? This whole architecture is built on moving safety from reactive consequence management, cleaning up the mess, to a proactive critical analysis of those latent failures.
The required sophistication of these documents really means that senior management's true core business is proving, through a documented process, that they have actively created the conditions for safety. The safety system isn't secondary to the project. It is the fundamental governance structure that allows the project to even happen.
A fascinating deep dive into a system that governs billions of dollars in infrastructure and, more importantly, countless lives. Think about this. If every organization involved in high-risk activity were legally required to formally document that they had considered one step too far in their risk mitigation, how fundamentally would that single engineering and ethical requirement change global decision-making? Something for you to mull over until our next deep dive.
If you're interested in the templates, please visit our shop, the link is in the description.
Thanks for watching, please subscribe and see next time.